This example, not quite so straightforward as the last one. We still need to find how much power, but we haven't been given the amount of work done, so we might have to do a step or two more to get there. What we know in the end is that we're going to have to deal with power equaling work divided by time. But since we're not given work, we will need to figure that out. The only equation we have for work is that work equals force times displacement. And while we do have the displacement of 21 meters, we don't have the force, so this might even be one more step beyond that. All we have for information besides that is the mass of 82 kg, and a key word here is lifting. So because we're lifting, we know that we're acting against gravity. And so what we can get to is we can go back to the older F equals ma equation, but specifically since we're acting against gravity, we can use F equals mg, knowing that g is 9.8 meters per second squared. So we can go back to find the variables. We know the mass of this concrete is 82 kg. We know the displacement of it is 21 meters. We know the time, 12 seconds. And from there we can go. So since F equals mg, mass of 82 kg times 9.8 meters per second squared would give us a force of 803.6 newtons. Not concerned about sig figs yet, since this isn't the final answer. We've still got 2 more steps to go. Going over to the work piece of this, work is force times displacement. So 803.6 newtons times 21 meters will give us a work of 16,875.6 joules. And now that we know work, we can calculate the power. 16,875.6 divided by the 12 seconds it took. And now we can take our final answer here to sig figs. We'll need 2 of them, and that would end up rounding to 1,400 watts.